Right, this is the application question from our Moore factor theorem lesson. So the question here says, the product of Ella, Franklin, Greg, and Hannah's ages is shown by the expression 5x to the 4 minus 9x to the 3 minus 57x squared plus 49x plus 12. Ella is the oldest, followed by Franklin, Greg, and then Hannah. So that means Hannah would be the youngest. Determine an expression for each of their ages. So an important word in this question is the word product. Product is the answer you get to a multiplication question. So anytime I see the word product, that means multiply. So that means if you multiply Ella, Franklin, Greg, and Hannah's ages together, you get that expression. So what I would like to do is take 5x to the 4 minus 9x to the 3 minus 57x squared plus 49x, oops, I missed the 9, plus 12. And I want to turn that into a multiplication question with 4 brackets, one for Ella, one for Franklin, one for Greg, and one for Hannah. How do we turn an expression into something with brackets? We factor, right? Factoring is the process of taking an expression and making a multiplication question that would give you that as an answer. So I notice this has 1, 2, 3, 4, 5 terms. So if we look at our factoring flowchart, there is a section for more terms. So I would look to see if there's a common factor. So I have 5, 9, 57, 49, and 12. I don't think those all have anything in common. They also don't all have an X. You can't group. You cannot group in pairs because there's an uneven number of terms. There are only 5, which leaves us with factor theorem. So we are going to try to factor this using factor theorem. You will notice there's a dotted line down the middle of the page, and you will see in a minute why that's there. So if I want to factor this, what I'm going to do is try to figure out a factor that I could try that will give me a value or a remainder of 0. So I'm going to try to list all the factors of the last term divided by all the factors of the first term. So I'm going to take the last and divide it by the first. So all things that go into 12 would be 1 and 12, 2 times 6, 3 times 4, and then 4 is already on my list, so I know that I'm done. The factors of 5 would be 1 times 5, and that's it. Those are the only ones we have. So to get my list of possible factors, I'm going to divide the numerator by each denominator. So 1 divided by 1 is 1. 1 divided by 5 is 1/5. 12 divided by 1 is 12. 12 divided by 5 is 12/5. 2 divided by 1 is 2. 2 divided by 5 is 2/5. 6 divided by 1 is 6. 6 divided by 5 is 6/5. 3 divided by 1 is 3. 3 divided by 5 is 3/5. 4 divided by 1 is 4. And then 4 divided by 5 is 4/5. The numbers could be positive or they could be negative. So my job is to now try subbing these numbers into my original equation and see if I can find one that gives me a value of 0. You just have to figure out where I put my calculator. All right, sorry, that took a second. Okay, so I'm going to sub in all the numbers that I can try. I think I might start with 1. I don't know. Sometimes you just kind of have to go with a feeling. You can start at the beginning and work your way through all of them. If you have a feeling about one of the numbers, you're welcome to do that. Just try those numbers. All right, I'm going to do 5 times 1 to the power of 4 minus 9 times 1 to the power of 3 minus 57 times 1 to the power of 2 plus 49 times 1 plus 12. And look at that. I got lucky on the first try. I got 0. So that means when I sub in 1, I get a remainder of 0. So that means x equals 0 is the number that gives me, nope, what am I writing? X equals 1, right? That number there is the number that gives me a remainder of 0. So the factor would be what I get if I take the 1 to the other side and do x take away 1 equals 0. So what this tells me is that one of these brackets up here is going to be x minus 1. Now, I don't know if that's Ella or Franklin or Greg or Hannah, but I know one of them is x minus 1. So that means down here, this part here is going to be x minus 1 times something. I just don't know what yet. So from here, I could keep testing values until I find one that actually gives me a remainder of 0 and try to see if I can find up to 4 of them. I say 4 of them because the degree here is 4. But instead, I'm going to do some long division, and I feel like I should not have written that there. I'm going to end up moving that lower just for spacing. So for right now, I'm going to white that out, and then I will write it down lower on the page a little bit later. Okay, so I want some room for my long division. That's why I'm moving it. Okay, so I want to know how many times does x minus 1 go into 5x to the 4 minus 9x cubed minus 57x squared plus 49x plus 12. I didn't leave myself a lot of room there. Okay, how do I turn an x into a 5x to the 4? I would multiply by 5x to the power of 3. So 5x to the power of 3 times x is 5x to the power of 4. 5x to the power of 3 times negative 1 is negative 5x to the power of 3. And then I subtract. 5 minus 5 is 0. Negative 9 minus negative 5, that's the same as negative 9 plus 5, which would be negative 4x cubed. And then we're taking nothing away from this, so it's still negative 57x squared. I'm not subtracting anything from 49, so that's still 49x. And then I'm not taking anything away from the 12, so that's still plus 12. Sorry, this is a 49. I forgot to write the 4. Okay, how do I turn an x into a negative 4x cubed? I would multiply by negative 4 and then x squared. So that's going to give me negative 4x cubed. Negative 4x squared times 1 is positive 4x squared. And we subtract. Negative 4 minus negative 4 is 0. Negative 57 minus 4 is negative 61x squared. And then I have 49x take away nothing, so that's 49x. And then I have 12 take away nothing, which is 12. Okay, how do I turn an x into a negative 61x squared? I multiply by negative 61x. So this is going to be negative 61x squared. And then negative 61 times negative 1 is positive 61x. Okay, negative 61 minus negative 61 is 0. 49 take away 61 is 12, negative 12. X. Oops, I wrote it in the wrong spot. Negative 12x. I forgot the 1. This is terrible. And then 12 take away 0 is 12. So I have negative 12x plus 12. How do I turn an x into a negative 12x? I multiply by negative 12. So that's going to give me negative 12x. And then negative 12 times negative 1 is positive 12. And when I subtract those, negative 12 take away negative 12 is 0. 12 minus 12 is 0. So all of that, I got a remainder of 0, which is good because that's how I came up with this number, was using a remainder of 0. So from here, that means that this is x minus 1 times, and then 5x to the 3 minus 4x squared minus 61x minus 12. So I now have one of the brackets. I know that one of the brackets is x minus 1, but I still need to factor this, and it's going to need to generate another 1, 2, 3 brackets. So I will see you in the next video where we tackle factoring that second bracket.